we ready?
We're on.
Okay, tickets.
Tickets in the bucket.
Smile. That's it. Smile.
That's right.
Very good. Good. Ticket. Ticket. No ticket. Can't come in. One of the two buckets.
Right here. Just take one.
Ticket. Ticket. Roll. Mind your seat. There's ushers waiting.
Thank you, sir. Make it official. Put your ticket in.
Make it official.
One in.
Make it official. Either one. You're with the ticket. You're on the way. All right.
Put one ticket in.
One ticket in.
Ticket. Go high.
Excellent. Very good.
Teacher got that ticket. Smile. And the camera.
Good job.
Ticket. Ticket. Camera. Wait, everybody wait. Wait for the camera. Wait, please. Wait for the camera.
Look at the camera straight ahead.
Wait for the camera. That's it.
Wait for the camera. You're on camera.
Right here. Right here. Right to your right. Give it away. Thumbs up.
Peace.
Thumbs up to the camera. That's it. Cool. That's it. Thumbs up. Good. That's it.
audience to give a big round of applause and thank you for coming. Among these volunteers, we have our wonderful supportive parents here with us today. We have your teachers, of course. And we also, at the back, if you all turn your head and look back there, you can see Mr. David Grader. He is. Here with us today. So make sure you're looking your best when you're doing your science experiments. There's going to be pictures going on. Yeah, take 10 seconds pictures. All right. Very good, very good. So, what we are doing today, I know the students have already seen a lot of the videos, but we are doing a science experiment that is going to try to break the record for the Guinness Book of World Records.
Mr. Yoli, please contact the office. Mr. Yoli.
So, we are going to do this, and we are going to start exactly at 1 o'clock, and all over Canada, all the way from St. John's to Victoria to Newfoundland, we have different schools coming together to do the exact same experiment that we are doing. So that is really, really cool, and I'm super excited. I can barely see last night. Anyone else? No? So, I want to show you a video that is a welcome for one of our Canadian astronauts. So we can just look at this video.
Across Canada, organizing an event that a new world record with most people taking part in a science experiment. Through experiments, we're able to validate existing theories, discover brand new ways of seeing things, and increase our understanding of how the world works. And sometimes what seems like an experiment gone wrong can lead to great discoveries that change our lives forever, like the discovery of penicillin. Later this year, I'll be blasting into space on a Russian rocket to reach the International Space Station, a huge orbiting laboratory. And during my 6-month mission, my crew and I will be performing over 100 science experiments on behalf of Canadian and international scientists. I hope that you can be part of this world record event. Join thousands of Canadians across the country. Have fun and learn.
All right, and now we have another guest that just arrived, and they're going to come up and say hi to you. So give a warm welcome to Mayor DJ, please.
Are you guys ready? Today, you guys get to make history. It's not every day that you get to be a part of a world record, and it's not every day that myself and my favorite MPP, Kim Crater, get to witness one. So we're really excited, and I just want to say, on behalf of City Council, on behalf of all the residents of Niagara Falls and everyone around the world that are going to take part in watching you guys be a part of history, I want to say congratulations. Thank you very much.
I just quickly want to say to the students in particular, I had the pleasure of being up front collecting the tickets when you came in. I asked you all to wave to the camera, and I saw some great smiles. Everyone waved. But more importantly, just as the mayor said, when I got an email from Kimberly asking me if I would come out, like many of you have done, the parents and the teachers, I didn't hesitate at all. So for the kids, this is really cool. I have never, in all the years I've been in politics, been ever asked to be a witness for a Guinness Book of Records attempt. So I want to say thank you, and anything we can do, we'll fill out the forms properly. But our goal is to get you into the Guinness Book of Records with the mayor and myself. So it's a pleasure to be here. Have fun.
Our time is quickly coming up. It looks like we have 1 minute to go. row until we are going to start. Okay, and we are going to start, we have to start with a signal. So when you hear the whistle, this is when we're going to start timing our timekeepers. And when we hear it again at the very end, this is when we're going to stop our timing. Okay, and then once you start, your groups are going to go quickly to grab your supplies on the table and come back. So wait for my signal. Okay, so everybody, take your string, hold it in half, cut it smooth, thumbs up when you're finished. Piece of string to each balloon, but make sure it's nice and long so we can dangle it, just like the name Waddell is going to show you up here. Our steps of how we're going to do our experiment. But I want you just to watch first and see how it's done, and then you're going to write your hypothesis after you see how we set it up. And the hypothesis is your best scientific guess of what you think is going to happen. So first, Madame Waddell is going to hold the balloons up by the end, about the same level as her head, right? So her head is like the same height as the balloon, right? And then the balloons are going to be nice and still, they're not moving. And then finally she is going to softly blow between the balloons. But before she does, I want you guys to talk in your group for 1 minute to see what you think is going to happen. Hypotheses, I'm not sure I'm French. So, what we're going to do is we're going to watch Madame Waddell and we're going to see what happens. Wow. Okay, you see that? The balloons, did they go together? Did that happen? Those balloons just kissed, right? That's okay. So, what happened there? My hypothesis wasn't that. I thought when we grew, we were going to blow balloons all directions. But it didn't. They went together. So, I want you guys to try that in your group. You're going to hold up your balloon. All right, go for it. Make sure every student gets So we want to write down what you saw, and if you're not sure, then I want you to make sure you can try to get it, and write down exactly what you're seeing if you haven't already. I'm going to give you 1 minute to jump down all the stuff you saw happen when you do it. Okay? I'm going to explain exactly why that happened. So, this is a balloon. We know this. And even though you don't see it, there is actually air all around the balloon, and it's pushing on all the sides of it. Do you believe me? Right. Teachers never lie. Always believe your teacher. So here we go. We have all this air pressure around your balloon pushing on it. And you know what? When this balloon's still, it means that all the air is pushing with the exact same amount of force. So the air that's pushing on this side is just the same as the air pushing on this side, so it's not moving anywhere. Does that make sense? All right. But the reason that air pressure is actually caused because air it's heavy, it has weight to it. So that actually is the weight of the air holding your balloon like that. So it's standing still. But the pressure is nice and equal, but what happens is when we have the two balloons and we're blowing, we're actually causing a decrease in pressure somewhere. So if I decrease the pressure on this side, that means that this side's weaker than the other side. And the other side pushes it where it wants it to go. So when you're seeing the two balloons, like this, and you're blowing between it, you're causing a low pressure here, so the outsides are powerful, and they shove them together so they kiss. But there's actually a reason that this is happening, and it is called Bernoulli's principle. And what it says is that when we blow, we're making air move. And when the air starts to speed up, the velocity of the air around the balloon is actually causing it to be low pressure. So when the air velocity increases, pressure decreases. Now, I know what you're thinking. I'm sure that's exactly what you're thinking. You're thinking, but Madame Clausen, when I blow, why is the air going around the balloon? Why isn't it going straight out? Well, that's a great question. Thank you for asking. So, what it is, when you blow, there's actually something called the Coanda effect. That's not on the test, just remember what it means. So Coanda effect means that when there's a stream of something moving, and that it actually really likes to stick to an object and follow it all the way around. So because we're blowing it likes to stick to the balloon, it wraps around, causing the airspeed to speed up, and in the center, there's low pressure, and then all of a sudden, mwah, they kiss. So don't be alarmed because the balloons are married, okay? So that's all right. So, I want you guys, that was our first experiment, and it is finished. We are heading on our second. So balloons, please, I want you to get them out of your reach and they're no longer in your hands. So put them to the side. rule that is called the water mister. For this, your materials, make sure you have them in front of you, are 1 cup, 1 straw per student. So every student is going to need their own straw. And you're going to need scissors and your ruler. Okay, if you do not, if you're missing any of those things, please put your hand in the air and the Yoka will come give them to you. Okay. Excellent. All right, so let's get started with our procedure. What are we going to do with this? So, the first thing we're going to do, and I want you to quietly do it, after you see her do it, I want you to quietly do it with your groups. That way we can go through it a little bit quick. So she's going to open the bottle. You twist like this. Perfect, excellent, everything that happens. Then you're going to pour it into your cup until it's 3/4 full. So you're going to have like this much space with no water at the top of your cup, okay? So, and then, it's very important to put the lid back on your bottle so you don't kick it over, please. So you may go do that now. Fill up your cup 3/4 of the way. Thank you. So your next step is going to be, you're going to need to take your straw, and you're going to take your ruler, and you're going to measure 10 centimeters, just about that much, and then at 10 centimeter mark, you're going to snip it. So cut it with your scissors. So you should have 2 straws, one 10 centimeters, and the other one's going to be just a little bit short, it's going to be around 7 centimeters.
Thanks for volunteering.
I know. Lots
All right, hands on your head, let's go. You guys are speedy, very good. All right. Next step, here it is. You guys need to make sure you're watching and then what else with this one. This time, she is actually going to pick out the shorter, her glass of water, but the short of the straw. Okay, not the long one, the short one. And she's going to put it in her glass of water. So the bottom of the straw is actually in the water, okay? You should be able to hold it though, don't let it go. Make sure you're holding it there. And then, don't start again, just watch her now. But everyone else going to take her second straw, the longer straw. And she's going to put them so they're just barely touching it. Just a little bit of overlap. And then she's going to blow a quick, short breath, but she's actually not going to, because first I'm going to give you 30 seconds to make your hypothesis. What would happen when she blows? glad you're excited about science. We need to make sure we stay on time. And as my class knows, I'm not good at staying on time. So we need to make sure we get through this here. So you're going to watch and actually see what happens first, because this is what should happen. As you will notice, there is this water misting out the end of the straw. This is a really good hint. I'm going to give you some good advice here. Do not aim it at people in your room. Not yet. All right, one more thing. You need to make sure everybody gets a turn. And there's a secret. If your straws aren't overlapping, it won't work. So make sure there's a little bit of overlap there. And also make sure to write down your observations. Make sense? But even when you insert your straw into the thing, you can actually barely see it move. It adjusts that quick because there are forces acting on this cup. There is stuff that we can't see. There is air pressure pushing down the water, and there's gravity. So that's why it's staying there. So there is pressure pushing on our water. And when we create low pressure over top of our straw, what happens is, it's like when you're pushing down on all the water with the pressure, and there's no pressure here, so it shoots up. It's kind of like what happens when you step on like a ketchup packet, and the ketchup shoots right up. All your pressure went down, so it had to go up. So the way we did that was we actually created, by putting the two straws together, this one was flowing into this one a little bit, right?
Oh no.
So because of the geometry of this again, so both experiments have to do with the shape. So it caused the air to follow the straw right along into the cup where it pushed down, and because of that, the air speed sped up and it didn't blow so hard. If you guys were blowing soft, you could see the water move up and down the straw. But if you blew hard enough, all of a sudden it created enough airspeed that went fast enough that the pressure became low enough on top of the straw that it could rocket out and mist on people. So that is what we call the Bernoulli effect. Everyone say Bernoulli effect? Excellent, very good. So that was our final experiment. I'm going to say one more thing about this guy Bernoulli. His real name was Danny, so I'm going to call him Danny. And that's his first name. He created this. He's sort of a Swiss scientist. And actually, he's super famous because this principle that we've been working on today is actually used for airplanes. And that's the reason why they can actually fly, is because of this pressure thing he figured out. So that is very cool. So one more thing, our science experiment now is going to be over. So our timer, you can go over the camera and click them off for us. We will end our signal now. Very good. So what we need to do as scientists, the first thing, because you're nice scientists, you're going to thank all the members of the group. I want you to shake hands and thank your fellow scientists. Thank you.
I'm not sure where those are.
You know what? We'll load them all up. So we just put them on the table over here somewhere. I'm gonna need to get this. Is it still going?
I think so. The kids were all saying goodbye to it, so you might have some.
Goodbye.
I was like, goodbye, Cameron. Bye.